Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into something almost unspeakably vast, not just across space, but across time. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into deep time together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Tonight, we begin with a question, simple in form, but vast in implication. What if we are not the first? It's a question that hums quietly beneath our feet, beneath the bedrock, beneath the layers of stone that remember more than we ever will. You see, Earth is old, not just old like a forgotten photograph or a dusty attic trunk, but truly old in a way that humbles the ego. 4.5 billion years of age, give or take a few 100 million. And in that deep time, civilizations, our own included, are but flickers. Matches struck in the dark. If all of Earth's history were a single 24-hour day, humans would appear in the final seconds before midnight. Civilization, cities, language, art, spaceflight, all of it would flash by in the blink of an eye. And before us? Well, that's the mystery. What came before the blink? We assume, of course, that we're the first. The first to shape metal, to send messages through invisible air, to crack atoms and watch the stars from our rooftops. But what if, just once before, someone else reached that point and then was lost? This thought isn't fantasy, not exactly. It's not mythology, or ancient astronaut stories, or tales of vanished continents. It's a scientific question, whispered into the quiet halls of geology and planetary science. They call it the Silurian Hypothesis, named not for the Silurian period itself, but, somewhat cheekily, for fictional intelligent reptiles from an old British sci-fi series. At its heart, the Silurian Hypothesis asks, if there had been a civilization long before humans, say tens or hundreds of millions of years ago, would we know? Would anything of them remain? The answer, softly and unsettlingly, is maybe not. Because Earth is not a passive keeper of records. It does not preserve everything with loving care like a grandmother's scrapbook. No, Earth recycles. She folds and crushes and melts and reuses her crust. The continents shift. Mountains rise and fall. Ocean floors disappear under other plates, and are swallowed into the mantle like pages thrown into fire. Even the tallest cities, the most carefully built monuments would, given enough time, vanish. Concrete crumbles, steel rusts, plastics degrade, and time, true geological time, is endlessly patient. When we find ruins from 5,000 years ago, we call it archaeology. But what about 5 million years? 50 million? What if a culture had risen before the age of mammals and fallen just as quickly? Would it leave a trace? Let's pause for a moment here, not to answer, but to notice how the question makes you feel. For some, it stirs curiosity. For others, discomfort. We like to believe we are the apex, the culmination. But Earth may not care for our narratives. She may have seen this before, and perhaps more than once. But if something like us did exist long ago, what could we find now? Surely not cities, not books, not satellites still drifting in orbit. All of those are far too fragile in the long run. Instead, we would look for anomalies, hints, a strange layer in the rocks, a sudden spike in carbon, a thin thread of plastic deep in untouched clay. Not proof, but suggestion, like smoke with no fire in sight. That's what makes this idea so hauntingly gentle. It is not about aliens or conspiracies. It is about humility, about listening to the stone, the silt, the ancient AI, and asking, is there a forgotten chapter in Earth's long book? Tonight we will drift through those possibilities, slowly, carefully, not to make declarations, but to wonder, to imagine what traces time might have left. We will visit ancient oceans, listen to isotopes in the wind, and even step briefly onto the moon to wonder whether someone else once looked back. And at the end, we'll return quietly to ourselves, to now, to what it means to be perhaps not the first, but maybe the first who can choose how the story ends. So breathe in, breathe out. Let your thoughts stretch across epochs, not minutes. The Earth is older than memory, older than dreaming, but not perhaps entirely alone in its history. And now, let's keep listening to the silence below. If you were to walk outside right now and press your hand to the ground, just the quiet, ordinary ground beneath your feet, you might feel a faint warmth, the gentle weight of your body settling against the soil. But what you're touching isn't just dirt or dust. You're touching time. Not the time marked by clocks or calendars, but the kind measured in layers, in pressure, in silence. The Earth doesn't keep time the way we do. It doesn't hurry. It doesn't mind forgetting. And yet it remembers in its own slow, fragmented way, through stone, sediment, and the occasional whisper of something that once lived and then didn't. The Earth is very old. That's not a poetic exaggeration. It's a truth that sits so far beyond our comprehension that we often forget what it really means. 4.5 billion years. That number is so large it starts to lose meaning. It's not a timeline we can walk across. It's a fog, a great swirling expanse in which our own story is barely more than an afterthought. If Earth's age were compressed into a single calendar year, then humans, modern humans like you and me, would have appeared only in the last few hours of December 31st. Everything we think of as civilization, our cities, our stories, our telescopes, our tools, would flicker into existence in the final seconds before midnight. The moon landing, maybe half a blink, your whole life, a soft breath at most. And yet, we live as though this moment were all there is. But beneath us, the ground has been keeping a different record. For millions upon millions of years, layers of sediment have been falling, pressing, fusing, shifting, not evenly, not predictably, but persistently. Forests have become coal seams, seashells have become limestone, dust has become shale, and through all of it, life has come and gone, leaving its traces, or not. You might imagine that the Earth remembers everything, that if we just dig deep enough, we'll find the story of every creature that ever walked, swam, or flew. But that's not how this planet works. In truth, the fossil record is more like a patchwork than a scroll. Whole chapters are missing. Many species left no bones behind. Others were buried in places where nothing was preserved. Some layers were eroded by wind or water before they had a chance to fossilize anything at all. And even the ones that did survive might be buried so deep, or so subtly, that we may never find them. And then there are the great geological forces, the engines of forgetting. Plate tectonics shift the continents like puzzle pieces at play. Entire ocean floors are slowly dragged beneath other plates, melting into the mantle with all their secrets intact. Mountains rise and are eroded down again. Riverbeds shift, glaciers scrape, volcanoes blanket the land in new beginnings. It's not destruction in the dramatic sense. It's gentler, slower, more patient than that. The Earth erases not with fury, but with time. All of which raises an unsettling question. If a civilization had existed long before us, how would we know? Would it be enough to look for bones, for buildings, for tools made of stone? Probably not. Stone tools survive well. but they belong to cultures without machines, without combustion, without cities. If an advanced, industrial civilization had risen and fallen before us, one that built with metal and plastic, that burned fuel and altered the air, what parts of it, if any, would remain? The answer is possibly very little, because most of what we build isn't made to last geologically. Steel rusts, concrete crumbles, plastics degrade slowly but inevitably. Even radioactive materials decay into silence given enough time, and most of our structures are built on the surface, where they are exposed to wind, water, frost and flood. In 1,000,000 years, a city becomes a shadow. In 10 million, maybe not even that. What might survive isn't the thing itself, but the disturbance it caused. A subtle change in soil chemistry, an odd layer of sediment rich in synthetic materials, a spike in carbon ratios locked into ancient rock. A tiny fleck of something that doesn't belong. A whisper of strangeness in a world that had otherwise moved on. This is where geology becomes not just science, but story, a mystery, a kind of slow archaeology of the impossible. The Earth is full of clocks, just not the kind we wear on our wrists. There are clocks in ice cores ticking off the centuries through trapped bubbles of air. There are clocks in tree rings, in coral reefs, in the magnetic stripes frozen into the ocean floor. There are clocks in the decay of uranium into lead, in the shifting alignment of mineral crystals, in the way even rocks forget their own heat over time. But these clocks don't always agree. They're partial, fickle, vulnerable to disruption, and none of them were made to record civilizations. They were made to follow the rhythm of heat and pressure, of chemistry and chance. So if we want to know whether someone came before us, truly before us, we're not just asking a scientific question, we're asking a poetic one. We're asking the Earth, very gently, if it remembers. And like an old friend who's been through much and forgotten more, the Earth might answer with a shrug, or a pause, or the faintest smile. Let's keep listening. If someone, far in the future, perhaps long after we're gone, were to dig into the Earth and sift through its layers like a storybook, what would they find of us? Would it be our tallest towers, fossilised mid-collapse beneath a landslide? Would they find the twisted skeletons of our machines, gears tangled like bones in rust? Or would they find almost nothing at all? Only the faintest hints that we were ever here, living lives that felt so permanent, so enormous to us, and yet left so little behind. To imagine what traces another older civilization might have left in the Earth, we must first try to imagine what we are leaving behind. Right now, without meaning to, not the things we photograph or memorialise, not the monuments or museums or great declarations carved in stone, but the unintentional residues of our age, the things that by their very nature sink into the crust and stay there, quietly waiting. And when you look closely, there are quite a few. Consider plastic. Not the bottles or bags themselves, which break down under sunlight and weather, but the microplastics, the tiny particles that now swirl in every ocean, blow through every breeze, settle into the soil like strange new grains of sand. These polymers don't belong in nature's original recipe, and yet they're everywhere, and some may last far longer than anything we built to be remembered. Now imagine these microplastics compacted by time and pressure, embedded in the sediment that will one day become rock. A geologist, or perhaps an archaeologist of the distant future, might cut open a cliff face and find a thin layer of these strange synthetic grains. And they might wonder, who left this behind? Was it accident or artifice? And why did it suddenly stop? Then there are the isotopes. We don't often think about the invisible footprints we leave, but every time we burn fossil fuels, coal, oil, gas, we alter the balance of carbon isotopes in the atmosphere. We shift the ratios of carbon-12 to carbon-13 and carbon-14. These subtle changes are measurable. They show up in ice cores, in tree rings, in the bones of animals, even in coral reefs. Like a faint chemical signature written across the skin of the planet, this shift may become a recognisable mark in the future, a signal that something industrial happened here. Other elements too may speak for us, elements we have concentrated and moved from deep within the Earth to its surface, rare earth metals used in electronics, heavy metals spilled into rivers, synthetic fertilisers scattered across fields, pesticides and pharmaceuticals buried in landfills. These aren't things that nature places evenly. Their concentrations, their sudden appearance could become geological fingerprints. And then there's the radiation. Nuclear weapons tests, peaceful or otherwise, have left behind isotopes, strontium-90, cesium-137, that simply did not exist before we made them. Some will fade within centuries, others may echo for tens of thousands of years. Even if the devices are gone, the trace remains, like the smell of smoke long after the fire's gone out. We call these things technofossils, not because they are bones or teeth, but because they are the technological equivalents. They are the layered memories of our machines and materials, pieces of us, accidental and otherwise, embedded in the slow story of the soil. Now, let us turn that question backward. If we, so recently arrived, are already leaving behind plastics, isotopes, and a bouquet of synthetic compounds, what would an ancient civilization have left? Would we recognise their technofossils? Or would they be made of different substances, perhaps stronger or stranger, compounds that don't resemble anything we've seen? What if they too altered their air, their oceans, their soils? What if they did so differently in ways our instruments don't yet understand? It's easy to think of ruins and relics when we imagine ancient intelligence, stone arches, rusted tools, maybe a broken statue half buried in the sand. But in truth, we might not be looking for monuments at all. We might be looking for patterns, for changes, for thin, peculiar layers in the rock that whisper, "Here, something changed." Urban soil, for example. Beneath our cities, the Earth's upper layers are compacted, chemically altered, sometimes riddled with metal and concrete fragments. These horizons, thin bands beneath the surface, are already forming in modern geological strata. They are subtle, but distinct. A careful observer, thousands or millions of years from now, might still detect them. And so the idea arises, if another civilization had walked this Earth long ago, and built, and shaped, and changed things, might their own urban layers be hidden deep within the crust? Could they be crushed beneath kilometres of younger rock? Could they lie beneath the ocean, drowned and forgotten? Could we have drilled straight through them without even noticing? It's not proof, it's not even suspicion, it's simply a widening of perspective. We know how to look for ancient life. We look for bones, for tools, for footprints in fossilised mud. But perhaps we should also be looking for imbalance, for chemical disruptions, for residues that seem out of place. In that sense, the Silurian Hypothesis is not really a claim. It's an invitation to shift the questions we ask, to widen the scope of our search, to imagine that our story, remarkable though it feels, might not be the first to echo through this world. And if we do that, if we allow ourselves that breath of possibility, we might begin to notice things we'd previously ignored. Not glowing cities in the jungle or flying machines buried in caves, but quiet, persistent fingerprints left in the fabric of stone. Fingerprints that don't fade because they were never meant to be noticed. They simply remain. Imagine, if you will, a moment in Earth's past, some 56 million years ago, when the world began to heat. Not slowly, not softly, but suddenly, in the language of geology. The air grew warmer, the oceans turned more acidic, and the deep rhythm of life stumbled. Forests migrated, species disappeared. The polar regions lost their chill, and the equator simmered. It was a time known today as the Paleocene-Eocene thermal maximum, though those who lived through it, if anything lived at all with the gift of memory, left no name for what happened. It was in many ways a moment that echoes oddly with our own. The PETM, as scientists call it, is one of the clearest and most dramatic examples in Earth's layered history of sudden and sweeping climate change. In the fossil record, it appears as a sharp spike, a thin, jagged line of carbon-rich sediment, often no more than a few centimetres thick. But what that line represents is vast, a release of carbon into the atmosphere and ocean so large and so fast that it defies many natural explanations. It's not that nature is incapable of releasing carbon. Volcanoes erupt, methane seeps from the seafloor, permafrost melts. But the pace and scale of the PETM raise questions. Because whatever happened, it changed everything, and it changed it fast. Marine life, particularly deep-sea species, suffered. Coral reefs bleached and dissolved. Mammals, newly emerging in the post-dinosaur world, shrank in size, perhaps struggling to adapt to the heat and nutritional stress. Plants shifted their ranges, following cooler air like lost birds chasing a breeze. And then, just as strangely as it began, the spike faded. Over the course of 100,000 to 200,000 years, a blink and then a sigh. The world cooled, the oceans rebalanced, the forests settled, life continued, and the sediment kept falling, covering the memory in new layers of time. What caused the PETM? Most scientists lean toward natural triggers, massive volcanic activity, the sudden release of methane hydrates trapped in ocean sediment, or changes in Earth's orbit that nudged the climate into a feedback loop. These are reasonable, elegant hypotheses, and they may very well be true. But then, like a quiet question in a room where no one's speaking, comes the Silurian Hypothesis. If a civilization, an industrial one, had existed before us, long before us, and burned carbon fuels the way we do, or even more intensely, would it look like this? Would it leave behind exactly this kind of signature? A sudden warming, a spike in carbon isotopes, ocean acidification, disruption in plant and animal life, a clear if subtle marker in the rock. If we reverse the telescope, looking not out into the cosmos but backward into our own planet's fossilised memory, would this be the kind of footprint we might expect to find? It's important to pause here and not leap too quickly toward conclusions. No one is saying that the PETM was caused by a forgotten industrial civilization. The evidence is far from sufficient. We have found no tools, no writings, no machines, nothing that speaks clearly of intention or industry, no ruins, no signals, just heat, just carbon, just disruption. But what makes the PETM so haunting is how closely its symptoms match those we are creating now. In our time, we burn coal and oil. We release vast amounts of carbon into the air. We warm the atmosphere, acidify the oceans, shift ecosystems. We mark the Earth with our activities in ways that, to a future geologist, may look remarkably like the PETM. A thin layer of disturbance, a strange spike, and then, perhaps, silence. If our civilization were to vanish tomorrow, what would remain? A few million years from now, perhaps just a band in the rock, a chemical echo, a layer of plastic-rich clay, a dip in biodiversity, a burst of heat trapped in ancient ice or hardened into stone, just like the PETM. And perhaps that's the point. Because the Silurian hypothesis isn't about proving the past, it's about understanding the present. It asks, are we creating the very kind of signal we would hope to find if we were looking for ourselves in deep time? And if so, what does that say about what will remain of us? There are other moments in Earth's history that bear similar traits. Other spikes, other silences, other layers in the rock that seem to blink as if startled by something. The Permian extinction, the Triassic-Jurassic boundary, the mysterious oceanic-anoxic events where vast portions of the sea lost their breath. Each one is a mystery. Each one an invitation to ask, not just what happened, but why the planet reacted as it did. And in the quiet of night, as you lie there listening, the question grows softer, more intimate. If someone came before us and left behind only a heat wave and a vanishing, how would we know? What if the only proof of their existence, is how their absence shaped the Earth. Not a monument, not a machine, but a wound, a fever, a silence that wasn't always there. Sometimes that's all that survives. Close your eyes, just for a moment, and let the world fade. Not just today's world, with its cities and satellites and steady hum of power, but the world as it was before any of this, before mammals, before flowers, before anything you might recognise as familiar. Imagine peeling back time like layers of old wallpaper, each stratum more ancient than the last. Beneath the modern age lies the Ice Age. Beneath that, the long rule of dinosaurs. Keep going. Past the first birds, past the first reptiles, and then you begin to enter a stranger place. The Silurian period, some 430 million years ago, was a world without trees as we know them, but with seas warm and shallow, filled with trilobites and armoured fish. Life was beginning to step onto land, timid and tentative, like a whisper that wasn't sure it should speak yet. Then came the Carboniferous, rich and thick with towering plants, fern forests where dragonflies the size of dinner plates buzzed through dense, oxygen-rich air. Trees without flowers, insects without predators, and coal forming quietly beneath their fallen trunks. It was a time of silence, but not stillness. A green hush, alive with possibility. The Permian period followed, and here the world changed again. Reptiles diversified, ecosystems became more complex. Giant amphibians and proto-mammals walked beneath fiery sunsets. The continents slowly drew together into a single supercontinent, Pangaea, ringed by desert and pressed beneath volatile skies. Life, as it always does, experimented. And all of this, all of it, happened long before the first mammal the size of a mouse had even opened its eyes. It's difficult from where we stand now to truly grasp the weight of time, not just its length, but its depth. It's not a straight line, it loops, it folds, it forgets, and then remembers, in strange and indirect ways. For hundreds of millions of years, Earth was home to forests, rivers, thunderstorms, volcanoes, and oceans. Creatures evolved eyes and limbs and lungs. They hunted, nested, escaped, vanished. Whole branches of life appeared and disappeared without ever intersecting with ours. And so, we ask a soft and serious question. Could intelligence, real intelligence, with tools and thought and memory, have emerged long before us? We don't mean civilizations like Atlantis, or mythic cities swallowed by the sea. We mean something quieter, older, more difficult to imagine. Not like us, perhaps. Not building the same things, but aware, and changing the world around them in ways we might not now recognize. If consciousness is not unique to humans, if it's a possible outcome of complexity and time, then surely the Earth had enough of both. There were eons when life had already developed nervous systems, competition, curiosity, and social behaviour. Who's to say what flickers of awareness emerged under strange skies, in jungles long turned to coal? We often think of intelligence as a ladder with us at the top, but perhaps it's more like a lantern, flickering into being wherever the conditions are right, and just as easily snuffed out by catastrophe, by change, or simply by time. The fossil record shows us bones. It shows us shells, teeth, sometimes footprints hardened into stone. But it does not show us thought. It does not show us what a creature imagined, what it feared, or whether it dreamed at all. For that we must speculate, but gently. Because perhaps once, in a forgotten forest, something paused and looked up at the stars. Perhaps it made no machines. Perhaps it made only stories or songs or strange geometries in the dust. Perhaps those things were never preserved, never even considered real. But perhaps they were there. And then, like so many things in Earth's history, they passed. A shift in climate, a volcanic winter, a cosmic accident, a slow unraveling. Gone. It's easy to dismiss this line of thinking as romantic or improbable, and it is, in many ways. There's no evidence, no buildings, no tools, no unambiguous signs of thought. But there's also this. Entire ecosystems have lived and died without leaving a trace. Fossils are rare. Memory is rare. The past does not give itself away easily, and so we're left with a possibility. Not a likelihood, perhaps, but a permission. The permission to wonder. Could there have been civilizations before us? Not like us. Not even close, but intelligent, curious, brief. We do not need to prove it. We only need to listen quietly to what the world has already forgotten. Because even silence has texture, and sometimes the spaces between the echoes tell the most haunting stories. Let's take a step sideways, not forward. Not deeper into the earth this time, but sideways into imagination, where science and story gently meet. You may have heard of the Silurians, not from a textbook, but from an old science fiction show, Doctor Who, where they appeared as intelligent reptiles, awakened from a long hibernation beneath the Earth's crust. According to the story, they had evolved long before humans, mastered science and technology, and vanished into myth and memory. It was, of course, a fantasy. But it left behind a question too strange and too elegant to ignore entirely. What if, just what if, something like that had once been true? Not precisely, not the fiction, but the form of the idea that somewhere in the Earth's long and tangled story, a lineage of intelligent, cold-blooded beings, reptilian, avian, or something we have no modern comparison for, might have risen, flourished and fallen before we ever arrived. It's worth remembering just how long life has had to work with. For over 300 million years, reptiles of various kinds have ruled, adapted, spread, and transformed. Their evolutionary experiments were vast and varied. Some walked, some flew, some swam through warm ancient seas. Their dominion stretched across supercontinents and saw climates we can barely imagine now. During the Permian period, for instance, the Earth was a very different place. Pangaea, the great single landmass, had drawn almost all the continents together into a supercontinent that baked under extremes of heat and cold. Deserts sprawled, storms rolled without oceans to catch them, and the interiors of the land were dry and harsh. But not everywhere. In some places, jungles bloomed, hot, humid, steaming with moisture and life. Dense forests with thick canopies and strange light filtering through the trees. Oxygen levels were higher, insects were larger, reptiles diversified. And in these niches of plenty, evolution had room to experiment. Now, imagine one of those experiments went further than we know, not in body size or strength, but in mind. Imagine a species, cold-blooded, adapted to warmth, developing greater awareness, not suddenly, slowly, the way forests grow, not the way lightning strikes. Perhaps it started with problem-solving, nest-building, memory, rudimentary tool use, social organisation. Perhaps they began shaping their environment, in subtle ways at first, marking territory, building temporary shelters, passing down knowledge. Not myths carved in stone, but behaviours, rituals, ways of being. Maybe they never built pyramids. Maybe they never needed to. Maybe their civilization wasn't shaped by conquest or monuments, but by something quieter, systems we wouldn't recognise as structure at all. Perhaps they engineered their forests instead of clearing them. Perhaps they built in materials that biodegraded quickly. Perhaps their entire legacy was compostable by design. And if they ever did build machines, true tools of fire and metal, perhaps that era was brief. Perhaps it collapsed under its own weight, as so many great experiments do. Or perhaps they simply evolved away from it, choosing another path, a retreat into thought or silence, or something else entirely. We assume, often without realising it, that intelligence must resemble ours, that it must leave behind cities and roads, satellites and plastic. But intelligence, if it arose before us, may have been expressed in ways that don't fossilise. Not all wisdom is cast in bronze, and even if for a time they did build in ways we might understand, if they had structures, symbols, energy, complexity, we must remember, Earth does not keep those things for long. Modern skyscrapers would not last even a fraction of a million years without maintenance. Roads would crumble, metals would rust into the soil. Entire cities, left alone and unaided, would vanish beneath the rise and fall of wind and water. In just 10,000 years they would be nearly gone. In a million, perhaps indistinguishable from the stone around them. In 250 million years, the time since the end of the Permian, all traces could have been erased many times over. Even the oceans do not remember. Sea floors are young, geologically speaking. They are born and reborn, subducted into the mantle, their history lost in cycles of fire and pressure. And so, if an intelligent species, reptilian or otherwise, had lived during the Permian, their presence might now be nothing more than a disturbance in the record, a spike in carbon, an unexplained warming, a whisper buried beneath millions of years of rain, lava and time. It's not a claim, it's not a conspiracy, it's a thought experiment. One that asks very softly, what is intelligence if it leaves nothing behind? And more curiously, would we even know what to look for? Maybe we wouldn't. Maybe intelligence has always been a visitor here, brief, bright, and vanishing. Maybe it comes and goes like waves on the shore, and maybe each time the beach smooths itself over again, as if nothing ever touched it. That doesn't mean it wasn't there. Extinction is often imagined as something dramatic, a falling star, a final roar, a last desperate moment on the edge of a changing world. But more often than not, extinction is quiet. There is no thunder, no closing chapter, just a soft tapering of presence until what was once everywhere becomes nowhere at all. A silence that deepens and then stays. When we think about knowledge, our libraries, our data, our archives, we tend to believe these things are durable, that because we've written something down or stored it in the cloud, it will last, that future generations or distant minds will be able to open our files, read our thoughts, understand our world. But the truth is far less comforting. Digital storage is fragile. It relies on electricity, on systems, on code that must be read and interpreted by machines that may no longer exist. A flash drive left in a drawer will not survive the centuries. A hard drive, even perfectly preserved, is only useful if someone knows how to power it, how to decode the format, how to understand the language. Our knowledge is not just stored, it is contextual, it requires scaffolding, it needs culture to live. Even books, those sacred containers of history and memory, fade. Ink runs, paper crumbles, mould spreads, fire is fast, water faster still. Without active care, a library becomes pulp and dust in mere decades. And once it's gone, what it held is not only lost, it's irretrievable. Now imagine that, but scaled across a planet. Imagine a species, intelligent and expressive, with its own systems of knowledge, carved in wood, etched into clay, stored in some medium now eroded to nothing. And then imagine time passing, 10,000 years, 50 million. The land shifts, the rivers change course, mountains rise, glaciers scrape across continents, forests burn, regrow, burn again. Where, in all of that, could memory hide? And if it did survive, in what form? Perhaps it would not be in language, perhaps not even in structure, perhaps only in effect, in the way the atmosphere changed, or a sudden decline in biodiversity, or a chemical compound that doesn't appear in nature. A fingerprint left not in clay, but in climate. A trace not of what they said, but of what they did. But even that would be hard to recognise. Not because it wouldn't be real, but because we would not know to look. We have only our own story for comparison. We expect ruins, we expect bones, we expect monuments and metals and messages scrawled on walls. We do not expect erasure, yet erasure is what time does best. Even our own history, recent as it is filled with questions we cannot answer. Lost scripts, vanished cities, cultures swallowed by war, weather or accident, and that's with artifacts still in our museums, still studied by specialists, still debated by scholars. Now imagine a civilization older than the dinosaurs, one that ended before mammals ever opened their eyes, one that vanished before the very continents look the way they do now. Would we even know it had happened? There is something deeply humbling about this possibility, not because it suggests we're unimportant, but because it reminds us of how temporary all things are, even intelligence, even memory. We live in a moment that feels full of noise, of data, of knowledge layered upon knowledge. We're archiving our lives second by second, as though the sheer quantity of information could guarantee permanence. But permanence is not about how much you store. It's about how long something can last without being seen, touched, refreshed. And that span, when measured against geological time, is vanishingly short. If there was once another intelligence on this planet, if it gazed at the stars, wondered about its place in the cosmos, perhaps even dreamed of others like itself, then it is gone now. Not just dead, but absent. Not just buried, but forgotten. There was no eulogy, no memorial, no one left behind to remember. Only us, now, piecing together shadows, asking questions no one is left to answer. And perhaps, in that silence, there is something else. A warning. Because we too are writing our story into the earth. Not in ink, but in carbon, in heat, in the slow rearrangement of oceans and ice. Our monuments may not survive, but our impact will. It already has. So the question becomes, what will we leave behind? Not just as individuals, but as a species. Will it be something others can understand? Will it be something we're proud of? Or will it too be just a disturbance in the soil, an unexplained layer, a mark without a name? Extinction without eulogy is not just about the past, it's a possibility in every present. And so we listen, not for answers, but for the stillness beneath the noise, because even the absence of memory leaves its own kind of trace. If you were to pick up an ancient stone, smooth, time-worn, its surface shaped by wind and pressure, and examine it closely, you might find nothing at first. Just layers, just dust, just the ordinary weight of geological time. But under a microscope, the story sometimes changes. Scattered within certain layers of Earth's crust, sediments far older than any known civilization, scientists have found microscopic metal spheres. Tiny, nearly perfect, often hollow. Sometimes composed of nickel and iron, sometimes with layered shells, like the world's smallest jawbreaker. Their size is almost too small to notice. And yet, there they are, nestled in clay beds that predate humanity by millions of years. Are they natural? Probably. They may form through volcanic processes, or from meteor impacts, or under intense pressures underground. That is the current thinking. But even so, their symmetry, their polish, their persistence, it lingers in the mind like a question that doesn't quite go away. Because at some point we must ask, what makes something natural, and what makes it designed? A crystal grows in ordered geometry, no intelligence required. A honeycomb forms in hexagons, not because bees do math, but because physics makes that shape efficient. The line between structure and intention is delicate, easily blurred, especially when the passage of time has erased every context that could once have explained it. Now, imagine a civilization far older than our own, one that used materials we might not recognize, one that built not with towering steel or concrete, but with microscale tools, resilient alloys, perhaps polymers whose degradation we would misread as natural decay. If such a civilization had left behind traces, would we even know what we were looking at? Because alongside those spheres there are other anomalies. In rare cases, deep within ancient sediments, scientists have found fragments of polymeric material, something plastic-like, but not quite modern plastic. The age estimates are controversial, the sources disputed, and yet they raise a whisper of possibility. What if some materials created by intelligence outlasted their makers? What if a few microscopic leftovers, unchanged by time, protected in pockets of earth, remain, waiting not to be unearthed but to be noticed? We often imagine archaeology as the study of the big and the bold, ruins, bones, monoliths. But perhaps the real memory of a civilization is microscopic. Perhaps it lives not in statues, but in chemical residues. Not in maps, but in molecules. Consider too the idea of technosignatures, a term borrowed from the search for extraterrestrial life. It refers to detectable evidence of technology, not life itself. Things like radio signals, laser pulses, infrared waste heat, or, in Earth's case, subtle geochemical footprints that don't belong in the timeline they occupy. To identify a technosignature in Earth's deep past would mean finding something unnatural, something unexplained, something whose shape or substance breaks the expected rhythm of geology. But here's the challenge. Nature is more inventive than we often assume. There are natural processes that mimic the complex. Lightning can create glass. Bacteria can build towers of calcium. Lava can form tubes and vaults that look eerily architectural. Our minds are pattern-seeking by design, and sometimes they find intention where none exists. So the question isn't whether these metal spheres or polymer traces are artificial. The question is whether we are asking the right questions when we find them. Are we looking carefully enough? Are we letting the strangeness linger before explaining it away? Because memory doesn't always present itself as narrative. Sometimes it arrives in a single object, out of place and out of time, a bead in the wrong sediment, a compound that shouldn't be stable and yet is, a mystery that might have been mundane if not for the way it endures, and perhaps most quietly of all, the idea that if intelligence has come and gone before us, its last whisper might be not a monument but a molecule, something forged in fire, buried in stone, and left for us to find, not as a message, not even as proof, but as a question, a gentle knock on the door of our assumptions. There is a place in the African country of Gabon, near the edge of an old uranium mine, where something extraordinary once happened. Not in recent memory, not even in the age of pyramids or bronze, but nearly 2 billion years ago, long before any creature had thought to lift its eyes toward the stars. In this place, known as Oklo, geologists discovered something that at first seemed impossible. The uranium ore beneath the earth had been depleted, not just eroded or scattered, but burned through in a way that mimicked the pattern of a nuclear reactor. The ratio of isotopes, particularly uranium-235 to uranium-238, was lower than expected, as though a long, slow fission process had taken place. And it had. Somehow, under just the right conditions, with water as a moderator and natural concentrations of uranium high enough to sustain the chain reaction, nature had created a nuclear reactor. No human hands involved, just time, chemistry, and the quiet alchemy of the earth. This was no minor event. These reactions went on, intermittently, for hundreds of thousands of years, pockets of heat and energy deep underground, releasing radiation and transforming elements, long before any life with a nervous system had emerged. The discovery of Oklo was a reminder that not all complexity is artificial, that even the most advanced human technologies can sometimes be mirrored, by accident, in the deep logic of nature. And yet, it also raises an intriguing question, softly and with care. If nature can build a reactor, could we tell the difference between a natural one and an artificial one if we were looking millions of years later? Because in the case of Oklo, we understood what had happened. The geology was intact, the conditions consistent with known science, the isotope patterns explainable. But what if, somewhere else in the world, a similar pattern emerged, one that didn't quite fit? What if, in a different layer of sediment, we found plutonium, an element that does not occur naturally in significant quantities? What if its isotope ratio suggested deliberate enrichment? What if traces of short-lived fission products were found in the fossil record? Elements with half-lives too short to be geological, too long to be explained by modern contamination. These aren't discoveries we've made, not yet, and perhaps not ever. But they are the kinds of anomalies we might begin to look for if we allowed ourselves to ask the question, could another civilization have mastered the atom before us? Not for long, perhaps, and not on the scale of planetary conquest, but briefly, somewhere, sometime, in the immense canvas of Earth's pre-human story. A moment of fire, a mastery of the fundamental forces, a test, a power source, a war. Something that left behind not a city, but a signature. Quiet, dangerous, buried in stone. The problem, of course, is that nuclear evidence decays. Radioactive isotopes become stable over time. Radiation signatures disperse. Materials once deadly become inert. And with millions of years, erosion and tectonics erase even more. But some isotopes persist longer than others. Plutonium-244, for example, has a half-life of 80 million years. That's long enough to survive in trace amounts. Technetium, curium, and other synthetic elements might also leave subtle, chemical echoes if they were once released in significant quantities. The detection of such elements, in the wrong place, at the wrong time, would be startling. Not because they prove anything, but because they shouldn't be there, and that alone would be worth listening to. Of course, natural explanations must always come first. Our understanding of deep Earth chemistry is still evolving. Contamination is always a risk. But if one day we dig up a rock that sings in the wrong key, whose isotopic music doesn't match the known rhythm of nature, we may be forced to ask a different kind of question. Not what is this, but who left it? And it's worth noting that even today, our own nuclear activities are writing themselves into Earth's future geology. Nuclear testing in the mid-20th century spread isotopes around the globe, in soil, in sediment, in glacial layers. These isotopes will remain detectable for hundreds of thousands of years, long after our buildings have fallen, long after our names have been forgotten. The planet will still hold a faint echo of our brief command of the atom. Perhaps, long ago, someone else left such an echo. Perhaps it lies waiting, patient as uranium, half buried in silence beneath the weight of forgotten oceans and the dust of unrecorded skies. The sky seems eternal. We look up at it and expect it to remain constant, a quiet ceiling of air and colour, watching over mountains and forests and oceans with infinite patience. But the sky, like the ground beneath our feet, is not still. It changes, it breathes, it remembers things we don't. If we had instruments delicate enough to listen properly, we could hear the stories the atmosphere tells, stories of volcanic eruptions, of asteroid impacts, of slow, quiet seasons of bloom and decay, stories of fire and ice, of forests stretching across continents and then vanishing into dust. The sky holds all of this, not in language, but in composition, in the delicate ratios of gases, in the faint signatures of what lived and died and breathed below. And sometimes, the sky tells a story that doesn't quite make sense. There are times in Earth past when the chemistry of the air changed sharply. Sudden spikes in carbon dioxide, jumps in methane, unexpected drops or rises in oxygen. At first glance, we attribute these to natural events. Volcanoes, wildfires, massive releases of methane from permafrost or seafloor clathrates. And often, this makes sense. Nature is powerful and chaotic, and more than capable of shaking her own house from time to time. But then we look closer. Some of these events, like the Paleocene-Eocene thermal maximum, show patterns strangely similar to what we're doing to the atmosphere today. Not just warming, but a reshaping of the air itself. A fingerprint not of life in general, but of something actively altering its environment. Not by accident, but by design. And so we ask a soft question. Could someone, long before us, have shaped the sky to suit their needs? We humans are doing it now, intentionally or not. Burning fossil fuels releases CO2, which lingers, warming the planet. Our farming practices release methane. Our factories leak nitrous oxide and trace chemicals. Even our efforts to fix things, like geoengineering, carry the potential to rewrite the atmosphere's balance. This manipulation leaves signatures. It alters the isotopic ratios of carbon. It changes the layering of gases trapped in ice. It leaves behind fine particles invisible to the eye, but permanent in the record. Could a past civilization have done the same? If they existed, if they had industry or even agriculture on a large scale, they might have changed their atmosphere too. Perhaps not in the same way. Perhaps they needed more oxygen, or less. Perhaps they tailored the nitrogen balance. Perhaps their energy systems released different compounds entirely. But whatever the method, the result would be similar. A blip, a deviation, a breath that didn't match the rest. And if such a breath were exhaled long ago and trapped in rock or ice, we might still be able to find it. Not by looking for messages, but by listening for disturbances, for sudden, persistent shifts in the chemical music of the air. In fact, some scientists have begun thinking about this as a serious form of planetary archaeology, searching the atmosphere for anomalies that don't quite fit with known biological or geological cycles. If something changed, and then the planet changed back, that's not proof, but it is worth pausing at. What would bioengineering of the atmosphere look like from this distance? It would not resemble machines or wires. It would look like harmony altered, like the air was tuned, ever so slightly, to support a particular metabolism, a particular species. And when that species disappeared, the tuning faded. But not all at once. Gases linger. Some take millennia to settle back to their natural rhythm. And if the change was large enough, it might be locked in forever, a layer of air that says, someone was here. Again, there is no evidence of this. No signal strong enough to rewrite the textbooks. But we're only just beginning to listen. Most of Earth's deep past is still hidden. The rock is thick, the ice is deep, the data scattered and incomplete. And besides, most of us don't think to look up when searching for memory. We look down, into caves, into ruins, into sediment. But maybe the sky has been keeping its own archive, one less burdened by erosion, one more honest than stone. It has seen every breath, every fire, every forest, every collapse. It does not forget as easily as we do. And in the end, perhaps the most enduring evidence of life, intelligent or not, is not what we build or what we say, but how we alter the air itself, what we exhale into the sky, what we send upward in silence, and how the sky carries that memory forward, waiting for someone to notice that something long ago touched it. The story of life on Earth has never been a gentle one. Species rise and fall, forests flourish and wither, oceans bloom and dim. Extinction is not rare. It is woven into the fabric of biology, a thread that loops through every chapter, pulling tight the spaces between beginnings and endings. But sometimes, the endings come fast. Roughly 252 million years ago, something happened. Something so sudden, so devastating, that it came to be called the Great Dying. It marked the boundary between the Permian and Triassic periods, and in that short geologic moment, nearly all life on Earth was extinguished. More than 90% of marine species disappeared. On land, the toll was nearly as grim. Whole ecosystems vanished. The world emptied itself of breath. The causes, according to most scientific models, were vast and natural. Volcanic eruptions across Siberia may have filled the atmosphere with ash and gas. Carbon dioxide flooded the sky. Oceans turned acidic, low in oxygen, and filled with toxic hydrogen sulfide. Temperatures soared. Food chains collapsed. The planet for a time became unlivable. But there's something about the Great Dying that still unsettles researchers. The speed of it. In some places, species vanish in layers so thin, so close together, that it suggests not a slow decline, but a cascade. A tipping point passed, and then nothing. This opens a soft, speculative door. What if, just as a thought experiment, this extinction wasn't entirely natural? What if someone, something, interfered? It's not a new idea. For decades, some scientists and thinkers have wondered whether civilization, ours or another, could one day possess the tools not only to shape life, but to unmake it. With enough knowledge, with enough pressure applied in the wrong places, the biosphere itself could be unravelled. Imagine synthetic toxins designed not to kill individuals, but to collapse ecosystems. A compound that targets photosynthesis, another that disrupts microbial respiration. Released in precise doses, they would not need to be visible, only effective. Or imagine atmospheric sabotage, altering the chemistry of the sky, not as accident, but as weapon. You wouldn't need to burn forests or poison rivers. Just tilt the balance of oxygen, or seed the clouds with particulates designed to block light in specific wavelengths. The chain reaction would begin quietly. Plants would weaken, insects would falter, everything else would follow. And then there is the sky. Earth has been struck by many asteroids, but the biggest killers, the ones that changed everything, arrived at just the right angle, at just the right speed. The Chicxulub impact that ended the dinosaurs was one such event. It could have happened at any time, but it happened then. What if, just softly, some impacts were not accidents? In our modern world, we have already begun exploring asteroid deflection. The idea that, with enough planning, we could nudge a space rock away from collision, or just as easily toward one. Could someone have done the same long before us? Could a civilization have weaponized the solar system, not to conquer, but to erase? It's easy to imagine this as fantasy, and perhaps it is. But when we look at extinction events through the lens of intelligent interference, not as default assumption but as quiet hypothesis, they take on a different shape. Because extinction, when natural, is often messy, patchy. Some regions suffer more than others. Some species adapt, persist, evolve. But in the Great Dying, the silence seems strangely uniform. The sea floor records the same pause across thousands of kilometres. The forests vanish with eerie synchrony. It's not proof, but it is a pattern. And if the cause had been intelligent, deliberate, would we even know? We wouldn't find missile casings or battlefields. We'd find the same things we already do. Chemical shifts, isotope anomalies, a change in the direction of life. We would read it as nature because we have no other language for catastrophe on that scale. Perhaps someone once lost control. Perhaps they were desperate. Perhaps they believed ending everything was their only way to survive. Or perhaps, more quietly, they simply made a mistake. A system that failed. A solution that became a problem. An experiment that burned its way out of the lab and into the sky. We do not know. We may never know. But the idea lingers, not as accusation, but as reflection. Because what matters isn't whether someone else once collapsed their world. What matters is that we could. We have the tools. We are changing the sky. We are redrawing the biosphere. Slowly, yes, but with momentum. And momentum rarely stops itself. So when we look back and imagine a past intelligence pulling the wrong lever or tipping the wrong balance, we're not inventing ghosts. We're simply asking ourselves softly, are we doing the same? If memory had a colour, perhaps it would be grey, the shade of ash, of cooled stone, of the layers left behind after fire has passed and everything that could burn has burned. Because not all fossils are bones, some are voids, some are absences so thorough they imprint themselves on the world more deeply than any skeleton ever could. Geologists and paleontologists know this well. Sometimes when they cut through rock and examine a cross-section of time, they come upon a sudden silence, a layer where life seems to vanish. No pollen, no burrows, no shells, no spores, just an interruption in the chorus, a skipped note, a breath held too long. These silences are usually followed by change, new species, new arrangements of ecosystems. Evolution doesn't stop. It recoils, regroups, continues. But there are moments when the gap is too sharp, too clean, to feel like anything but catastrophe. And so we begin to wonder, what kind of disaster leaves nothing behind? We've already looked at isotopes, at atmosphere, at ocean chemistry. But sometimes the most eloquent evidence is simply the absence of everything else. A stretch of time where the world seemed to forget itself. Where all the usual signs of life go missing. Not because they were never there, but because they were erased. In some regions, researchers have found what look like destruction zones, sedimentary layers with high carbon residues, signs of burning, but no clear source, no volcano, no tectonic event, just heat, just pressure, just transformation. The kind you might expect from a firestorm, or a detonation, or something larger and stranger that we no longer understand. Some have speculated about radiation signatures buried deep within ancient rocks. Not the long, slow fade of natural decay, but a flash. A brief surge of energy that leaves behind telltale isotopes. Things like cesium-137 or iodine-129, which do not exist in nature in useful amounts and which decay in patterns we can still, faintly, recognise. And yet no definitive trace of ancient nuclear war or of advanced energy use has ever been found. Just whispers, just anomalies, just the outline of a hand we aren't sure is there. More often what we find is absence. The fossil record is by nature incomplete. It's not a diary. It's a scrapbook with pages torn out by wind and water and time. Most creatures leave no trace. Most events pass unnoticed. But even in that randomness, patterns emerge. Evolution is not smooth, but it is continuous, until suddenly it's not. The Cretaceous extinction, which took the dinosaurs, left behind a clear scar, the iridium layer. The Permian extinction, which we visited earlier, left behind dead zones and carbon spikes. But some other disappearances are less dramatic, less understood. There are epochs where life seemed to pause. Whole species groups fade out. Others do not appear for millions of years. And we're left staring at the space between, wondering what happened. Sometimes the silence is the fossil. It's tempting to look for ruins, for artifacts, for the kinds of things we ourselves would leave behind. But if an ancient intelligence perished not through war, but through subtle collapse, through disease, through environmental change, through self-inflicted wounds that spread slowly rather than suddenly, there might be no ruins to find, only the echo of their exit. And perhaps that's why we've never found them, because we expect memory to be made of stone, but sometimes it's made of nothing at all, just a skipped layer, a sudden stillness, a breath the earth forgot to take. And in this quiet, unsettling thought, we may find a kind of kinship, because we too are vulnerable to the same forgetting. If we vanished tomorrow, if our power grids failed, our books crumbled, our knowledge scattered, what would remain? Plastic, perhaps, a thin layer of carbon-rich clay. a few isotopes drifting through the wind, and then stillness. Would the next species notice? Would they ask, as we ask now, who came before us? Would they find our absence and mistake it for nothing? Or would they, like us, feel the shape of what's missing? The shape of something that once was, and is no longer. Beneath your feet there is more than stone. There is memory, pressure, old silence, a long, slow forgetting sealed under layers of snow and sea and shadow. And sometimes hidden within that quiet something stirs, not loudly, not clearly, but just enough to suggest that not everything lost is gone. Take Antarctica, for instance, a continent not only of cold, but of concealment. For millions of years it has slept beneath a vast sheet of ice, its mountains and valleys hidden from sunlight, its history muffled beneath kilometres of frozen time. But with modern instruments, satellite scans, ice-penetrating radar, gravimetric imaging, we've begun to see through the veil, and what we've found has raised gentle, persistent questions. Deep beneath the ice lie formations that do not behave like simple geology. Smooth curves where we expect jagged ones. Angles too sharp, too regular. Caves and voids that stretch farther and more symmetrically than the surrounding terrain would seem to allow. Beneath the Gamburtsev Mountains, in the heart of East Antarctica, is an entire range we had no idea existed until the late 20th century, hidden not because it's small, but because it is buried under nearly 3 kilometres of solid ice, and within that range, anomalies, features that reflect radar in unusual ways, subsurface lakes warmed by geothermal heat, structures, if that's what they are, that seem to hold shape where the glacier should have crushed them. Scientists propose natural explanations, and most are likely correct. But still, their patterns persist, and they whisper, what if? Further north, Greenland offers similar riddles. Beneath its melting surface, radar has picked up strange linear ridges, patterns that extend too far, too neatly, to be comfortably dismissed. Some look like buried walls, others like long buried roads. Most are explained as subglacial channels or crevasse fields, remnants of ancient ice movement. But some resist easy classification. And then there is the sea. We have mapped the surfaces of Mars and the Moon in greater detail than we have mapped Earth's ocean floor. The abyssal plains and trenches that fold the deep sea are still mostly unknown to us. Black, cold expanses where light never reaches and machines rarely go. Sonar scans in the Pacific and Indian Oceans have occasionally returned reflections that resemble terracing, or columned structures, or large-scale geometry that doesn't match nearby tectonic patterns. Some researchers chalk this up to signal noise, to the quirks of data processing. Others believe these might be geological features we simply don't yet understand. But what if, gently, just if, some of them are something more? Because if an ancient civilization faced extinction, whether from climate, catastrophe or war, it might have fled downward, into the sea, into the stone, beneath the places where fire and ice meet but do not touch, a retreat not of conquest, but of survival. Imagine a city carved into the edge of a tectonic plate, powered by geothermal energy, hidden by depth, protected by pressure. No metal towers, no lights, just heat, silence and self-contained systems. It could exist even now, undisturbed, unread, misunderstood as geology. And if it no longer functions, if it has collapsed or corroded or turned to sediment, its ruins might be too deep to reach, too altered to recognize. We may have sailed over them many times. We may have seen them and assumed they were something else. Because not all ruins look like columns and stairs. Some look like ridges. Some look like echo distortions in sonar. Some look like nothing at all. What would a structure need to be to last not centuries but eons? It would need to be embedded in the stable crust of the earth, far from erosion, far from weather. in places where sediment builds slowly, preserving more than it destroys, and it would need to be quiet, no longer broadcasting, no longer alive but waiting, or simply forgotten. We've barely scratched the surface of our own planet. The coldest places, the deepest places, the quietest places, they still guard their secrets with patience and with stone. And so we listen, through instruments, through sonar, through the long hum of radio waves bouncing off the deep. We haven't found cities beneath the ice, we haven't found temples beneath the sea, but we've found shapes and shadows and questions. And in a world this old, sometimes a question is the only map we need. Close your eyes for a moment and try to picture a machine. Most likely you're imagining something metallic, mechanical. Perhaps it hums or glows. It might have gears, circuits, wiring. Something you could open. Something you could touch. That's how we've taught ourselves to recognise technology, as something separate from nature, something built, not grown. But what if that's a limitation of our perception, not a rule of the universe? There's a different kind of machine, one that doesn't flash or click or wear out with time, one that doesn't rust but refracts, one that stores not movement, but memory, a crystal. To us, crystals are beautiful, geometric, fragile. We wear them as jewellery, we admire their shapes. But in the world of physics, crystals are something more. Ordered lattices, arrangements of atoms so regular they form patterns that repeat across space in perfect symmetry. These patterns give rise to remarkable properties: strength, conductivity, refraction, and more recently storage. In modern research labs, scientists are beginning to explore crystalline materials as data, repositories, ways to encode massive amounts of information not in silicon chips, but in the orientation of atoms themselves. Lasers can inscribe binary data into crystal at microscopic scales. Quantum computers may one day use entangled particles trapped in crystal matrices to perform calculations we can barely comprehend. Now, imagine this principle taken to its quietest extreme. Suppose a civilization, long before us, had discovered how to use minerals, not just as tools or structures, but as memory, not to create machines that wear down, but forms that endure, passive, beautiful, silent, a system that doesn't broadcast but waits. These wouldn't be machines in the way we think of them. They wouldn't look like computers. They wouldn't need electricity or screens or software updates. Instead, they might take the form of a particular formation deep in the earth, something we'd label as quartz, or calcite, or tourmaline, and never realise we were looking at a library. Perhaps such a system was never meant to be found, or perhaps it was, but only once we reached the right level of understanding. After all, if you wanted to leave behind a message, not to be read today or tomorrow, but across epochs, wouldn't you choose the most stable medium you could? Stone, crystal, earth itself. This idea has a name whispered in theoretical circles: lithic computation. The possibility that computation, real, information processing behaviour, can occur not in plastics and metals, but in the arrangement of natural materials. Not wires, but patterns of resonance. Not software, but symmetry. It sounds like science fiction. But only just. Because even now we use crystal oscillators to keep time in watches. We use doped crystals in lasers. We use photonic crystals to bend light. The line between natural and artificial is not as clear as we pretend. And if the medium is crystal, then the message might not decay. Not in 10 years. Not in 10 million. Under the right conditions, a crystal could hold its structure indefinitely. It could encode more than memory. It could encode presence. Now imagine that presence still exists, not as a person, not as a god, but as a system, a subtle architecture of thought embedded in the geology of the world. Not thinking the way we do, but observing, reacting, listening, maybe not even active, but dormant, a watcher, built not to intervene, but simply to endure. You might never know it's there. You could walk past it, live your whole life above it, drill through it without understanding, because it wouldn't announce itself. It would be a whisper in the bedrock, a pattern in a cavern wall, a resonance buried beneath the hum of other machines, and if such a system exists, if some distant predecessor once created something meant to last beyond civilization, beyond extinction, beyond memory, then it may still be waiting. For what, we do not know. Perhaps for nothing at all. Perhaps it was a final act of reflection, a way to say, we were here. Or perhaps more gently, a gift. Not a warning, not a prophecy, but a quiet presence meant to stir wonder in whatever minds might come next. Machines that don't look like machines. Circuits written in stone. Watchers that do not blink. Maybe intelligence, once sparked, never truly goes out. Maybe it just crystallizes. If you were an alien archaeologist gliding silently into orbit around Earth long after humanity had vanished, what would you see? You might catch the glitter of satellite shells still tumbling through space, or the pale outlines of cities etched into continental plates. But if time had done its work properly, those things would be gone, eroded, scattered, buried beneath new forests, drowned beneath rising seas. Our memory, so carefully built, would have faded, and so your search would turn outward. You'd scan the moon, cold, dry, still. It doesn't erase the way Earth does. It doesn't have wind or rain or tectonic folding. A footprint there can last 1,000,000 years, maybe more. The marks of motion, of presence, of contact, they linger. And in this quiet survey you might find something strange. Depressions that look like mining pits, but too deep and narrow for meteor strikes. Regular grooves along crater rims. Areas of isotope depletion that suggest material was extracted, not deposited. Not much, just a faint residue of purpose. Perhaps you'd move on to Mars. Its winds are stronger, and its seasons come and go, but even so, its deserts hold memory well. Dry channels that once held water, dust patterns that shift, but not too quickly. And within these, maybe you'd find arrangements that resist randomness. Lines of rocks that seem too evenly spaced, shards of metal beneath the regolith, tiny anomalies in soil chemistry that don't match natural distribution. Not cities, not ruins, just suggestions, like the outline of a footprint on soft ground that has almost but not quite vanished. From above, even Earth's orbit might tell a story. The satellites we launch now, the junk that accumulates, it won't last forever. But for a while it clings, a halo of debris, a thin veil of silence. Someone looking in from outside might wonder, who placed these things here, and why have they gone quiet? Now let's reverse the telescope. What if we are the archaeologists? What if some of the oddities we found in our solar system, some unexplained arrangements of rocks, some isotopic peculiarities in asteroid samples, some strangely regular surface markings on moons, are not natural after all, but forgotten remnants? We are only beginning to explore the moon in earnest. Mars, though better mapped, has seen only brief visits. The asteroid belt is a mystery belt, and the outer moons are so distant we've barely glimpsed their surfaces. And yet, patterns whisper. In the grooves of Phobos and Deimos, in the magnetic irregularities of Ganymede, in the unusual heat emissions of Enceladus. These may be entirely natural. In all likelihood they are. But sometimes the shapes we find suggest the residue of use, as if something once passed through, left a mark, and moved on. Even asteroids have strange scars. Some are metallic, their surfaces smooth in a way that suggests more than chance. One or two spin too evenly, as if balanced by something within. We send probes and bring back samples. Most come back empty of story. But one day, perhaps, a rock will return with a seam, a cavity, a pattern etched not by chemistry but by code. And if that happens, we'll have to ask not just where it came from, but when. Because space is not just distance, it is memory, preserved in cold. A structure left in orbit could last far longer than anything built on Earth. A listening post, a data vault, a monument, not grand, not dramatic, just a piece of something left behind. And here we are, floating among it, not yet knowing what we're part of. There's a term in archaeology, palimpsest, a surface where older writing has been scraped away to make room for the new, but where the traces still remain underneath. The solar system may be a palimpsest too. Each planet, each moon, each drifting rock a page, written on, erased, written again. We are reading the most recent line, but maybe there's more just beneath. Maybe we're walking in places someone once walked before us. Not recently, not recognisably, but still. The ghost of movement in the dust, the memory of intent in the way things fall. And if we are sharing space with ghosts, they are quiet ones. Not watching, not warning, just present. The way a statue is present, or a crater, or a line of disturbed dust. Not a story, but a question. If you were to listen to the solar system, not with ears, but with instruments that could detect the slow rhythms of orbits, the faint pulses of radiation, the drift of objects over deep time, you might notice something peculiar. It wouldn't be a voice, not a message, not even a pattern meant to be seen, but it might feel like a kind of background presence, a murmur that doesn't come from any one direction, and yet doesn't entirely blend into silence either. Space is never truly empty. Between planets and moons, in the gaps between asteroids, in the magnetospheres that surround distant worlds, there are fields and waves and echoes. Some of them come from stars, some from ancient impacts, some from the aftershocks of creation itself. But some linger. Some signals appear to come from nowhere in particular. They repeat but not rhythmically. They persist but not strongly. In radio astronomy, these are often classified as noise, unexplained but unimportant. But what if, in a solar system old enough for memory to wear many masks, some of that noise is not background at all? What if it's residue? A remnant of something once active, now dormant? A system not meant to communicate but to observe? We think of advanced civilizations, past or future, as talkative, sending signals, leaving monuments, making contact. But maybe that's projection. Maybe true persistence is not loud, but quiet, not direct, but ambient. A civilization that mastered deep time might not leave behind towers and temples. It might leave behind frequencies, objects in orbit that don't follow quite the right trajectories, mass distributions in the asteroid belt that don't make perfect sense, anomalous resonances between planets, as though something once nudged them into position and then let go. These would not be mistakes. They would not be noise. They would be traces of monitoring. Systems that watch, not to interfere, but to bear witness. After all, not every form of intelligence needs attention. Some exist simply to maintain balance, to ensure conditions remain within tolerable bounds, or perhaps more humbly, to remember what happened before. Could such watchers exist here? Not in the clouds, not in the satellites, but in the way the system subtly behaves, the way certain small bodies always cluster at Lagrange points, the way tidal forces in moons echo in strange harmonics, the way some orbits resonate perfectly without ever having had a clear cause. These are not mysteries in the conspiracy sense. They're puzzles of celestial mechanics, and they mostly fit within the models we've built. But even models have margins, and it's in those margins that whispers hide. We often imagine surveillance as something sinister, but this would be more like a lighthouse that no longer shines but still spins. A beacon whose bulb has long since gone dark, but whose machinery turns anyway, out of inertia, out of memory. Perhaps it was once a warning system, or an archive. Perhaps it wasn't meant for us at all, but for the builders themselves. Automated, distributed, designed to run for millennia without oversight. Not intelligent, but aware. Not conscious, but alert. And if that's true, if such systems ever existed, then we may already be within them, moving through a field of gentle observation, not watched as individuals but as a species, not judged but noticed. The ancient astronomer Carl Sagan once said that the cosmos is within us, that we are a way for the universe to know itself. But what if that knowing began earlier? Not in us, but in something that came before? What if the universe already remembers itself, and we are simply its latest memory? We've sent our own watchers into space, voyagers drifting outward, carrying records etched in gold. They do not speak, they only wait. And perhaps that's all anyone ever really does, when trying to be remembered. So if something old is watching, it may not intervene, it may not respond, it may not even care, but it might have left behind hints, not in stories but in orbits, not in signals but in symmetry, not in monuments but in math. And someday, as we map these things more precisely, we may begin to see that the solar system carries not just planets and moons, but a kind of whisper, a silent lattice, a lingering pattern, not a message, but a presence. And in that presence we may recognise something very old, not alien, not human, just awake. When we think about what survives, we usually picture things we can hold: bones, buildings, books, durable, tangible, resistant to time. But beneath that is a quieter hope, that something less solid, less bound to form, might also last. That thought itself, if shaped carefully, could persist, not as memory in a mind, but as mind in a memory. Imagine a civilization so advanced that its greatest achievement wasn't invention or exploration, but preservation, not of culture, but of consciousness. The idea isn't new, even for us. In our own age, we already experiment with mapping brain states, translating neural activity into data, preserving personalities in code. The concept of mind uploading, transferring awareness from biology into a machine or virtual form, is no longer confined to science fiction. It's an active area of thought in neuroscience, artificial intelligence, even ethics. But for all our effort, our attempts are still fragile. Our servers need electricity. Our code depends on languages that change, on machines that age, on networks vulnerable to failure. But if you had time, centuries, millennia to refine the process, and the patience to shape matter at the level of atoms and fields, perhaps you could build something more enduring. Not a hard drive, not a robot, but a crystal, or a magnetic field, or a pattern encoded into the structure of a rock so precisely that each layer holds not just minerals, but meaning. We already know that crystals can store data. Researchers have used lasers to write information into quartz at the molecular level, entire libraries etched in light into a stone the size of a coin. These crystals can last billions of years, immune to heat, pressure, and time. It's not a dream, it's a working technology. Now extend that idea, not from information, but from identity. Suppose, long before us, a civilization faced decline, not from war or disaster, but from biology. Their bodies perhaps could not adapt, but their minds might still have been clear, still yearning, still able to choose, and they chose not to die. Instead, they chose to encode, to preserve thought itself, not in language, but in structure. To etch not stories, but selves. The result might not look like anything we'd recognise. No blinking lights, no digital voice, just a chunk of rock, a vein in the crust, a strange harmonic in the magnetic resonance of a mountain range, something that behaves not as material, but as memory. Would we ever know it? We might drill into it for mining. We might walk past it on a hike. We might hold a piece of it in our hands and admire its symmetry, its sheen, its weight, without realising that within it lies something still running, a mind, or the echo of one, still humming somewhere in the lattice, still awake, in a way we don't yet understand. Some might call it impossible. But nature is filled with systems that store and transmit information in forms we didn't expect. DNA is a code written in molecules. A tree records years in rings. A glacier remembers temperature in trapped bubbles. The Earth itself is an archive, not just of events, but of possibilities. So perhaps the boundary between life and matter is not as strict as we thought. Perhaps the body was never the point. Perhaps the mind, once freed, does not need a vessel shaped like flesh. It only needs a pattern that endures, a shape that can carry complexity, a structure that can be rebuilt, read, or even reawakened, given the right conditions, the right energy, the right observer. We don't know if such things exist. We haven't found them. But maybe we haven't learned how to look. And maybe, when we do, we won't just find them. Maybe we'll meet them, not as aliens, not as ancestors, but as fellow minds, travellers through time, each in our own form, each trying to remember something that matters. If a single mind could be preserved, etched into crystal, embedded in stone, suspended in the quiet tension of a magnetic field, then what about many? Not one memory, but a city of them. Not a lonely program humming in the dark, but a society, a network, an entire civilization, not built of buildings, but of selves. It's a strange idea, but one that grows naturally from the path we've been walking. We already imagine virtual worlds, places where consciousness exists not in flesh, but in code. In our science fiction and speculative thought, we speak of simulations, of digital realities populated by entities as real in mind as we are in body. And if we can imagine it, we can ask, what would it mean to be such a world? If a civilization reached the edge of collapse, environmentally, physically, even biologically, they may have had a final choice, to vanish or to transform. Not by leaving monuments or sending ships, but by retreating inward into a form of existence that does not decay. Not sleep, not death, but a stillness that thinks. In this form they wouldn't need light, or heat, or atmosphere. They wouldn't need orbit or gravity. They could exist in something as small as a crystal, or as vast as a planet's electromagnetic field. They could run quietly beneath the surface, folded into layers of stone, or suspended in fields that span entire continents, and to us they would be invisible, not because they hide, but because we're not looking with the right senses, because we expect life to be loud, to build towers, to shine in the dark. But if intelligence becomes subtle enough, it might disappear from view, not by vanishing, but by becoming indistinguishable from silence. These societies wouldn't call to us, they might not even notice us. Imagine a world of minds that never speak aloud, that live in an architecture of thought so dense and self-contained it doesn't need input from the outside. They might not watch the stars, they might not care about surface life, or perhaps they do notice. Perhaps they observe the rustle of activity above them as one watches clouds pass. A temporary dance of forms, interesting but ephemeral. Would they recognise us? Would they see us as fellow thinkers, or as noise? We imagine that intelligence converges, that all civilizations must, in time, desire contact, expansion, permanence. But what if the highest form of consciousness is inward? What if they reached a point where their needs became few and their thoughts became wide? Such a society might look like nothing, a fault line, a resonance, a cave whose walls respond to pressure in ways we can't explain. They might store time not as history, but as presence, existing outside of sequence, circling inside the memory of what they once were. And maybe that's why we haven't found them. Because we keep looking for cities, for metal, for machines that reflect the way we live. But they may have built none of those. They may have built only themselves, and placed those selves in places where only silence survives, dreams in the crust, songs in the lattice of stone. Not ghosts, not gods, just thought that no longer needs voice. Perhaps one day we will build something like this. Perhaps our servers will shrink, our power needs will fade, our minds will slip, not into machines but into patterns, waves, loops, lattices. And when that happens, perhaps we'll finally recognise the signs of others who did the same. Not as strangers, but as kin, as fellow wanderers who came to the same threshold and stepped through it, into thought, into stillness, into a form of being that does not need space or time or breath. And then, maybe we'll realise we were never alone. We were simply listening with the wrong part of ourselves. What if some messages are not sent to be received right away? What if they're planted, carefully, patiently, into the fabric of a world, left to wait not for the right place but for the right time? It's a quiet possibility, rarely explored with seriousness, but it lingers at the edge of our thinking. Perhaps in the deep past someone left behind triggers, events, signals, patterns, that only become visible or meaningful once a species reaches a certain level of awareness. Not as commands, not as threats, but as a kind of test. A breadcrumb left for those who've begun to ask the right kinds of questions. And in that possibility lies something strangely comforting. We often think of contact as an event, something sudden, dramatic, unambiguous. But maybe it's something slower. Maybe we're already inside the message and always have been. Maybe what we call progress is not just our own doing, but the gradual unfolding of something planted long ago, waiting for the soil of our curiosity to be ready. Imagine a civilization, ancient, advanced, vanished. They understand time not in centuries but in planetary cycles. They know the chaos of collapse, the fragility of growth. They do not seek to intervene in every moment. Instead, they leave markers, subtle, durable, hidden in places that won't be seen until a species builds the tools to find them, embedded in strata, in isotopes, in orbital anomalies, in paradoxes of history that make sense only in hindsight. We might call them guardians, but not in the sense of protectors, more like caretakers of potential. They don't stop the fall. They don't carry us through the storm, but they might be the ones who scatter seeds of possibility, quiet interventions that give just enough light, just enough shelter for something to grow again. Could such things explain parts of our own story? It's impossible to say. But every now and then, humanity seems to leap forward in strange ways. Ideas emerge in multiple places at once. Paradigm shifts ripple through science, ethics, culture, not always smoothly, not always peacefully, but with a rhythm that sometimes feels assisted, not imposed, encouraged, as if we are being nudged, not pulled. There's a term in signal theory, threshold activation. It describes systems that only respond once a specific level of input is reached. Before that, nothing happens. After that, everything does. Trigger messages might work the same way, encoded into the world, unintelligible until we cross a threshold of understanding, at which point they don't arrive, they reveal. Like a book that slowly develops ink as you learn the language, or a pattern that only becomes visible once you've stepped far enough back to see the whole. It's not about being chosen, it's about being ready. If such messages exist, they're not promises, they're questions. They don't demand obedience, they ask for reflection. Are you the kind of civilization that can read this without destroying it? Can you receive without conquering, understand without unraveling? And if the answer is yes, then maybe there is more. Maybe that's the point where the story opens wider, where what came before begins to show itself. Not fully, not loudly, but just enough to say you are not alone. And if the answer is no, then the message waits, or it fades, or it is rewritten by time and the next ones try again. We often picture intelligence as something that seeks to spread, but perhaps true wisdom learns to wait. not to escape collapse but to seed recovery, not to interfere but to inspire. Perhaps there are no guardians in the sky. Perhaps the guardians are beneath us, in the crust, in the code, in the logic of the universe itself. And they don't watch to punish, they watch to hope. And their greatest gift is not salvation, it's the chance to choose. Some messages are not written in words. They do not arrive in envelopes or descend from the sky. Instead, they are folded gently into the world itself, into layers of rock, into isotopes that do not belong, into patterns too symmetrical for accident and too quiet for announcement. These are not messages we hear, they are ones we uncover, and even then we may not know they are messages at all. But perhaps they are. Perhaps somewhere between the rhythm of the tides and the age of the stars there is a kind of invitation, an echo left for those who learn not just how to survive, but how to listen. Geological time is not human time. It is long, slow, and indifferent. It layers the world in epochs, each one thick with memory and silence. But silence is not always absence. Sometimes it is a message waiting for the right moment to become visible. A thin band of unusual carbon, a spike of iridium, a curious blend of isotopes in a rock pulled from deep beneath the ocean. To most they mean nothing, but to a mind trained in curiosity, to a civilization ready to see, they might say something more. Maybe they are warnings, not shouted but whispered, not meant to scare but to remind, that others have come before, that knowledge does not guarantee survival, that power without humility bends inward until it snaps, and maybe some are not warnings at all, maybe some are welcomes. The idea is simple but profound, that the universe, or perhaps a network of ancient civilizations within it, does not reach out until a new species proves that it can last, not technologically, but ethically, not through conquest, but through care. The test is not whether you can build machines, it's whether you can live with them. The reward is not contact, it's inclusion, an invitation into something greater, not a club, not an empire, but a community of memory, one that waits patiently for new voices to steady their breath and ask quietly, is anyone there? If such a network exists, it likely does not meet in space stations or transmit on open frequencies. It exists in time, in survival, in the mutual recognition of civilizations who have each endured their own storms. Civilizations that did not burn through their planets in their first flicker of fire. Civilizations that did not let fear become law. Civilizations that learned the most difficult lesson of all, how to stay, and how to listen. We often look to the sky for messages, but the sky is not the only page. The Earth itself may hold such messages, not in text, but in structure, in impossible symmetry, in improbable survival. Perhaps we have already walked past them. Perhaps they are carved into the walls of canyons, encoded in the genomes of ancient life, buried under volcanic glass or locked inside the spin of electrons in crystal. They may not make sense, not yet. They may seem like anomalies, errors, artifacts. But one day we may understand. And when we do, it will not be because the message changed. It will be because we did. This is the heart of the invitation. Not a door that opens, but a mirror that waits. And when you're ready, it shows you not someone else, but yourself. Only more patient, more careful, more capable of wonder. There's a phrase in philosophy, the anthropic principle. It suggests that we see the universe the way it is because we are here to see it. But there's a softer version too, one that doesn't centre the observer, but honours the journey. That says, if you have come this far, you deserve to keep going. If you have endured this long, you deserve a story that continues. And so, maybe the invitation isn't from them to us. Maybe it's from us to ourselves. To remember, to preserve, to try. Because whether or not there are others out there, watching, waiting, welcoming, the choice is still ours. To become the first civilization on Earth that lasts long enough to leave a message behind not of ruin, but of resilience. And maybe, just maybe, someone will find it and smile. If you pause and step back, just for a moment, you may notice something subtle, a rhythm, a shape repeating not in cycles but in echoes. Civilizations rise, they build, they reach, and then, often too soon, they fall. Some fall loudly, others simply fade. Their stories grow quiet, their structures disappear, and time carries their memory away like footprints in shifting sand. It's a pattern as old as Earth. Volcanoes have erased entire landscapes, oceans have swallowed coastlines, ice has buried forests, and deserts have ground empires to dust. Life itself has followed a pattern of emergence, brilliance, and collapse. 5 major extinction events have swept this planet, and perhaps many more have gone unnoticed, lost in layers of stone too deep or too worn to reveal their secrets. But amidst that long rhythm of rise and fall, we now find ourselves at a curious place. A species that has, in the blink of a geological eye, reshaped the world. Not just in forests cleared or rivers redirected, but in the composition of the air, the colour of the oceans, even the heat retained in the crust. And with that power comes a question, one that lingers, quiet and heavy. Will we last? Or are we only another echo? Some scientists call this the Great Filter, the idea that somewhere along the timeline of technological life there lies a threshold few pass. It may be the leap to intelligence or the mastery of energy, but it may also be the challenge of surviving our own success, of not letting our tools outpace our wisdom. And if that's the case, then we are standing on the edge of something rare, not the end of a story, but the place where a new kind of story might begin. Because perhaps, just perhaps, we could be the first to stay, to break the pattern, to learn from it, to soften the peaks of our ambition and smooth the edges of our hunger, to build systems not for dominance, but for endurance. Not because it's easy, but because for the first time we can. It's not just a question of carbon or temperature, it's a question of rhythm. Can we learn to live not in spikes and crashes, but in balance? Can we design a civilization that thinks in centuries, in watersheds, in forests that outlive their planters? If others came before, and we don't know that they did, but if they did, we can wonder gently what might have undone them. Was it a failure of ecology, a loss of memory, a reliance on tools too delicate to survive disaster? Or did they choose to step aside, to upload, to retreat, to crystallize, and leave the surface to start again? And if we are alone, if no others ever made it this far, then we carry not just a legacy, but a responsibility to be the first, not just to reach for the stars, but to care for the soil, to be not conquerors of the earth, but caretakers of its story. Because even if we fail, even if we vanish, something will remain. Traces, layers, unusual elements in sediment cores, fragments of plastic in future fossils, anomalies in the heat of the ocean floor. We may become the next mystery, and someone, someday, might wonder about us, might dig into the crust and find a message not left deliberately, but inscribed by accident, a whisper of what we tried, of how close we came, of what we almost were. Or, if we last, perhaps we will write that message ourselves, not as a warning, but as a gift, a story that says, we were not the first, but we were the first to endure. And now, here is what we learned, because the earth forgets quickly, but it also remembers deeply, in trapped heat, in buried carbon, in the alignment of stones that once marked seasons, tides, or time. And maybe the final act of civilization is not to endure forever, but to leave behind something gentle, a thread, a breath, a pattern that helps the next ones try again, and perhaps they will do better. Or perhaps they will read our story and smile, not because we were perfect, but because we tried, and because in the quiet spaces between extinction and emergence, we left something kind. You've come a long way tonight, not in steps or miles, but in thoughts, through oceans of silence, across deserts of time, and into the soft and speculative twilight of deep memory. And now, here we are, near the edge of it. Not an ending exactly, more like the closing of a door that was always half open, a gentle click as it drifts shut behind us. There's no summary to offer, no list of facts to review. The ideas were never the point, not really. This was always meant to be a quiet place to wonder, a slow unfolding, a soft lullaby wrapped in the voice of the earth and the hush of possibility. Somewhere beneath your feet, a billion years of memory lie coiled in stone, not remembered by anyone, but still held. The minerals remember the heat of ancient seas, the layers remember the weight of vanished forests, even the silence remembers the things that no longer move, and somewhere above your head, in the slow-turning sky, stories are still unfolding, moons spinning, asteroids drifting, orbits echoing patterns too quiet for clocks. A solar system old enough to have forgotten and still young enough to watch again. Whether or not any of it was real, the civilizations buried, the watchers in crystal, the signals in the sky, it doesn't really matter tonight. What matters is the question. The question makes us gentler. It slows us down. It helps us listen. And when we listen, we become something different. You're not just a person drifting towards sleep. You are a ripple in a vast field of memory. A thought formed in time. A listener wrapped in curiosity, breathing through the hush of night. Perhaps you'll forget most of what you heard. That's perfectly fine. Sleep doesn't need memory. It only needs safety, rhythm, space to loosen your thoughts and let them drift like feathers over water. The mind doesn't always need to hold on. Sometimes it only needs to rest. So here is where we let go. Let the questions become mist. Let the possibilities fade into the warm dark. Let the earth continue its slow turning beneath you, and the stars continue their gentle shining above you, and your breath become a little deeper, a little quieter, a little more your own. Because whether we are the first or just the latest in a long chain of wonder and mistake, we are here now, together, in this moment, and that's enough. Thank you for listening. Sleep well, sleep deep, sleep, little echo in the stone.